We have f of x equals 3x to the negative 1, and h of x equals x plus 4 over 3. And they ask you to find h of f of x. I've seen a lot of you guys doing a good job of plugging in what f of x is equal to. So f of x is 3x to the negative 1. And then h tells you that whatever's in the parentheses, you're going to add 4 and divide by 3. That's the rule. Add 4 to the parentheses and divide by 3. So I'm going to say 3x to the negative 1 plus 4. I add 4. I divide by 3. Now, you've done the function composition part of this, but there's some simplification that can happen. For instance, what is x to the negative 1 power equal to? 1 over x. Good. And so over here I can simplify this as 3 times 1 over x plus 4, and this is still all over 3. When I have a fraction times a whole number, how do I multiply 3 times 1 over x? Drew?
Cross.
Good, I go across. What's underneath the 3? There's a 1 hidden there, right? So 3 times 1 is 3. And 1 times x is x. And this is still plus 4 over 3. Right now, you should already be able to see a domain problem. What number can I not plug into this function?
0.
Why? Good. I can't plug in 0 because I can't divide by 0. Are there any other numbers that I can't plug in? Can I plug in negatives? Can I plug in positives? Can I plug in decimals? Yeah, I can plug in. The only number that's bad is 0. So already right now, without doing any other work, you can tell what the domain is. The domain is all real numbers except 0. The shortcut for all real numbers, by the way, is a big double R. If you write double capital R like that, that means all real numbers. And then you could say except 0. There's your domain. Now over here, there's still some simplification we can do. For instance, how do I add a fraction and a whole number? You find a common denominator. Right now, underneath the 4 is a 1. What's the common denominator between x and 1? X. So I need to multiply this side by x on top and on bottom, because I need to get a common denominator to be able to add the fractions. When I do that, I have a common denominator, it's all over x. What do I do with the 3 and the 4x? Can I put those together and make 7x? No, why not? It's a 3 and a 4x, they're not the same, they're not like terms, right? So I have 3 plus 4x on top, and this is still all over 3. The last thing you can do here, if this is 3 over 1, Stephen, what's that rhyme for dividing fractions?
Dividing fractions is easy as pi, flip the second, multiply.
Dividing fractions is easy as pi. Flip the second and multiply. I like to say flip the bottom too, but whatever. So we've got 3 plus 4x over 3, over x. Dividing fractions is easy as pi. Flip the bottom and multiply. So you flip it, the reciprocal, right, and make it 1/3. And now anything times 1 stays itself. So 3 plus 4x. And anything times the bottom, so x times 3 is 3x. There's your final answer for h of f of x. Now, none of the other problems are this detailed. You will, however, on number 33, need to remember that x to the negative 1 equals 1 over x. You'll need to use that on number 33.